Hello, welcome. Let's try to solve another Leetcode problem 1015, smallest integer divisible by k. So we are giving a positive integer k, and you need to find the length of the smallest positive integer n such that n is divisible by k and n only contains the digit 1. So we're going to return the length of this number n. So if there's no such number, we're going to return a negative 1. So this n may not fit into so here we need to take care of this note. So this n may not fit into a 64-bit side integer. This means this n going to be a really big value. It can be really big. And the value of k going to be 1 to 10 to the power 5. So this means if this n going to be a really big number, definitely it's not possible to use the brute force. I mean, we're going to try 1, 11, 111 until we try maybe how many ones? Maybe 5,000 ones. But that is not possible. Because in programming we cannot calculate such big numbers. So what are we going to do? So what are we going to do to solve such problem? So here we need to be careful about what we are giving, and we need to find some numbers, and all those numbers like 1, 11, or 111. Some things, all those numbers are going to be like this. So in the third example, as we can see, 111, it is divisible by 3, so the length is going to be 3. And for this number 2, definitely it is not possible. Because you see, we found some numbers 1, 11, definitely it is not possible to be divisible by 2. But if it is 1, it is possible. If we choose a number 1, so definitely this is possible, because 1 divisible by 1, it is 0. So we're going to directly return this number. It's going to be 1, and the length of the 1 going to be 1. So what properties can we get? So let's just imagine this is our number. It's going to be like this. So for example, if the first number is a, if the current number is a, so let's set it as a current number. So what's going to be the next number? So the next number is going to be 8 times 10 plus 1. So definitely this is okay. Now what are we going to do? We're going to try to use the modular, because in mathematics, if we use the modular, definitely we can get the number smaller and smaller. And if we want to use the modular, let's just copy here. If we want to calculate the modular, so for example, if we want to calculate this modular, 8 times 10 plus 1, and modular a number which is going to be k. So what's going to be this result? And what is the relation between a modular k? Is there some relations? If there's some relations, definitely we can solve this problem. Maybe we can find a formula. So 8 times 10 plus 1 modular k, so going to be equal to something going to be like this. Let's put it 8 times 10 modular k. Because in mathematics we can use the modular formula. So it's going to be 8 times 10 modular k plus 1 modular k, and after that it's going to be a modular k. And this formula we can continue to calculate. So here we just imagine this k is not equal to 1. It's going to be more than 1. So if this k is more than 1, so definitely definitely it means k going to equal to 2 or 3 or something else, but k is not equal to 1. Otherwise, here going to be 1 modular 1 going to be 0. So if k is not equal to 1, so this formula we can continue to calculate. So let me just copy it. So from here, this 1 modular k, because k not equal to 1, so it's going to be 1. And inside, it's going to be this one. Let me just copy it. Let's continue to calculate. So this one going to be equal to here. So inside this one, let's calculate from here. So 8 times 10 modular k. So what's going to be this one? So it's going to be a modular k plus 10 modular k, and after that it's going to be modular k plus 1 and modular k. Yeah, so this is just the mod operation. So currently, what about here? A modular k. So this is a modular k. So we're going to set this a modular k. So this is the current number, and this is going to be the next number. Yeah, or you can set this is the previous number, this is going to be the current number. It doesn't matter. So a modular k, we're going to set it to x. Yeah, so if a modular k equal to x, so inside here, so it's going to be x, right? So let me just copy and paste. So inside here, it's going to be x plus 10 modular k. Yeah, because we're going to set a modular k equal to x. So x plus 10 modular k and modular k plus 1 modular k. And because this x is a remainder, so we're going to use this x modular k, because it's going to still equal to x. But we can combine these operations together. So let me copy and paste. So from here, this one is going to equal to, so this is x modular k plus 10 modular k modular k. So we can combine this one to x times 10 modular k. So this is going to be x times 10 modular k. Now what happens? So this is the current number, it is x. And what is the next number? The next number is x times 10 modular k. So this means we can use this formula directly to get the final result. So we're going to set x equal to this one, x times 10 modular k. X is going to be the current result, which is a modular k, and x times 10 modular k is going to be the next number. So let's just use an example. Maybe we're going to use 3 maybe. So k is going to equal to 3. We're going to use the last example. Yeah. So k equal to 3, and the first one we're going to choose 1. So 1 modular 3, definitely it's going to be 1. So 1 modular 3 is going to equal to 1. So this is going to be the first number. And what is going to be the next number? Yeah, because this is 1, so 1 times 10, it is 11. 11 modular k, k is 3, so 11 modular 3, it's going to become 2, right? So 2 is going to be the next number, because it is 11 modular 3, it's going to equal to 2. So what about the next number? Yeah, because currently this one is 2. So 2 times 10, I'm sorry, this is x times 10 plus 1 modular k. Yeah, let me recalculate it. So this here is just some mistake. It should be okay because I forget to plus this one. Yeah. So if x from the beginning 1 modular 3, it's going to be 1, and then 1 times 10 plus 1 is going to be 11 modular 3, it's going to be 2, and the next 2 times 10 plus 1, it's going to be 21. 21 modular 3, it's going to become 0. So what happens? So so the last one is 21 modular 3, it is 0. So this means we've already found the answer. So the answer is going to be 3. Because from the beginning, it is only 1, and then it is 11, and then it is 21. This 21 actually means 111. We just make it smaller by the modular operation. Yeah. Now, this means we can use a set to calculate the result. We just need to put all the numbers inside the set, and finally, we're going to calculate the set. So the length of the set plus 1 is going to be the final result. Otherwise, there are going to be duplicate numbers inside the set. So for example, k equals to 2, it's going to be duplicate numbers inside the set, and we're going to return a negative 1. Yeah, so this is going to be the final solution. Yeah, so here, because we find a 0, definitely we're going to stop it, and we're going to return the final result. Yeah, so we're going to prepare a set. So inside of the set, it's going to be all the possible remainders. Yeah, so in this way, the time and space complexity is going to be okay, and k is going to be 10 to the power 5. So this is okay for Leetcode. Yeah. Now for the first number, we're going to set it to x. X is going to equal to 1 modular k, because we are not sure about k. This k might be equal to 1. if this k equal to 1, 1 modular 1, x gonna become 0. So we're gonna set this x. If x is not 0, or x is not inside the set, so we're gonna update the result. So otherwise, finally, we're gonna return a negative 1. So if there's a value of x, but we just go out of the while loop. So otherwise, we're gonna return the length of the set plus 1. But in between, let's just check it. So if it is not inside, definitely we want to put this number inside the set. And then we're going to use this formula to update the final result. Let me just copy and paste. So x is going to equal to x times 10 plus 1 modular k. And you can just use some numbers. For example, this number is put it inside to check why this formula works. And this is why we can get this kind of a formula. Yeah. Now let me just run it. Yeah, I hope there is no infinite loop. Oh, there is an infinite loop. Let me have a check. So while x or let me think about it. I think it should be add while x add x not inside is s. So this means if x equal to 0, we're gonna stop the loop. Otherwise, if we use or, I can never stop the loop. Yeah, because if this is not inside, even this is inside, but this value x, it's gonna have a value, maybe 2 or 3, but I can never stop the loop. Actually, I want to use add. If this value is x not equal to 0, and this is not inside the set, so I'm gonna continue to do it. So if this x already equal to 0, I'm gonna stop it. Yeah. Or if this is a 0, if this x is not 0, but it is inside the set, it means this can maybe 2 or 5 or some other numbers. It's gonna have an infinite loop, so we're gonna stop it. How can we find this infinite loop? Because we're gonna use this set. Because we always use the modular. It means it's gonna be at most 10 to the power 5 numbers. Definitely we can find the infinite loop. For example, k equal to 2. Yeah. Now let me just run it. Now as you can see, it works. Now let me just submit it to check if it can pass. As you can see, it passed for all testing cases, and it's pretty fast. Thanks for watching. See you next time.